Okay, let's look at stem and leaf plots. A stem plot or stem and leaf plot is a graph that displays numerical data. All data values are shown. It has two columns. They have a stem and they have a leaf. The stem holds the group value and the leaf holds the final digit. We'll show that by way of example. The following stem plot shows the sizes of 20 students' DVD collections. It's really important that you have a heading, DVD collection size of 20 students. You also must have a key. So with this key, if there is a score of 2 in the stem and 5 in the leaf, that stands for 25 DVDs. So here is the number of DVDs that these 20 students have. This score here is 4. This score here, a 1 and a 4, so a 1 in the stem and a 4 in the leaf, is 14 DVDs. So a 1 in a stem and a 6 in the leaf is 16 DVDs. 2 stem, 2 leaf, 22, and onwards up to the most DVDs anyone had, 5 and 6, is 56. So that's how we input stuff. So for example, this score here, 3 and a 6, that would be this one here, that student who had 36 DVDs. A stem and leaf plot, you can see the distribution of data is quite evident. This is a normal or symmetrical distribution because the outer scores, so the score here and here, they're smaller and it gradually peaks and then goes back in. That's what we call a normal distribution. Let's look at worked example 9. The following scores represent the distance in kilometres travelled by a group of people over a particular weekend. So I've got my heading, distance travelled over one weekend. I've got my stem and my leaf ready because the least distance anyone travels looks like maybe 2 kilometres and the most that anyone travels is 105. So I've got to start from 0 on the stem and right up to the 10. My key, a 4 in the stem and a 7 in the leaf means 47 kilometres. So let's do this. This first person travelled 48, so it would be 4 in the stem, 8 in the leaf. 67, 6 and 7. 87, 8 and 7. 2 would be 0 and 2. 34 would be 3 and 4. 105 would be 10 there and a 5 there. 34 again. 45. 63. 98. And I think you get the picture. I'll fast forward and input the rest. But before I do that, it's important that the scores are in order too. So here we've got a score of 48 and a score of 45. I need to write them so that the scores are in order. So the score of 45 comes first and then 48. So down here you can see there's a score of 67 kilometres and 63. I write them the other way around. So yes, you put them down, but then you must make sure they're in order. Okay, so I've quickly put the rest of the scores into my stem and leaf plot, made sure that they're all in order. So for example, here we've got 41 kilometres, then 44, then 45, then 48. Yes, I've got my heading up here. Yes, I've got my key. Let's comment on the shape of the distribution. Is it symmetrical? It's not really symmetrical because we'd expect it to peak like in the middle, which is in like the 50s, but it's peaked here in the 30s. So most people travelled, if you like, between 20 and 50 Ks in this group here. So, sorry, those 8 and 9 have gone big, I'm not sure why. So no, it's not symmetrical because most people travelled around 20 to 50 over the weekend. And only 3 travelled over 70 Ks, so we'd say no, it wasn't symmetrical. Let's look at our next example. The heights of 30 students. Represent this in a stem and leaf plot. Okay, I've quickly done that here. I've put my heading, heights of 30 students in centimetres, put my key, 11 in the stem and 8 in the leaf means 118 centimetres. And I've put that data into a stem and leaf plot. What we often do if we have particularly large leaves, so these are quite large leaves, they're quite long, be much easier to interpret this data if the stem was broken up into smaller intervals. So what we do, if you look here, look at these scores here. We have split them up. This row here is just 12, and it's all the numbers in the leaf up to, but not including 5, so up to 4. Then 12 star is all of these scores here from 5 onwards, so from 125 centimetres onwards. Let's look at our 13. So all the scores up to here, below 5. So all these scores here are listed here, and all the 13 scores greater than 5 are broken up here. Okay, there was no need for us to break up the 11s, so we still call it 11 star because it's the second half of the 11s, the scores after 115. And again, we haven't got a 14 star. We would, if a new student came to the class that was 146 centimetres, for example, we would put 14 star and then the 6 there. So you might sometimes have to do or see stem and leaf plots like this, where if you've got a particularly long leaf, it's easier to interpret with the stem broken up into smaller intervals.